Hello friends, I am Professor Khadi from Department of Mechanical Engineering. Today I am going to discuss the basic terminology or basic terms used in gear from theory of machine subject. Gear to profile, you can see in the figure the basic figure of gear to profile. Here I am going to explain you which areas or which surface you can see in different angles. If you see in different angles, this gray shaded area you can see in front view of the gear. This yellow shaded portion of the gears you can see in side view of the gear, and this green shaded area you can see from the top view of the gear. So if you see the orthographic projection of complete gear, you can see the image like this. This is the orthographic projection of gear. In front view, you can see the gear, actual gear in gray shaded area, gray shaded portion. Actually, gear is a blank disc, circular disc, in which material are removed to form the teeth. The teeth which are engaged with each other to transmit the power. In front view, you can see the circular disc and the teeth, and inside view, you can see the gear as a rectangle portion, and these horizontal lines is nothing but a projection of teeth. By different manufacturing process, the material is removed from the surface of the teeth. The diameter of the circular disc you can see in the front view, and the width of that disc or gear you can see in side view, or the thickness you can see that you can say the thickness in side view. Now the first term which is used in terminology in spur gear is pitch circle. Pitch circle is an imaginary circle on gear which by pure rolling action would produce the same motion as the actual gear. In this figure, you can see the pitch circle. This is the pitch circle shown in a red dotted line. Pitch circle. Secondly, next is pitch circle diameter. Pitch circle diameter, it is nothing but the diameter on pitch circle, and it is denoted by alphabet D. As discussed in earlier YouTube channel in basic of spur gear, it is mentioned that gear is always used in pair. The small gear is called as a pinion or driver, and the larger size gear is called as a driven or gear. So if diameter of small gear is smaller, it is denoted by small d. So pitch circle diameter, which is shown here, is denoted by small d, and pitch circle diameter of gear is shown by capital D. This is required for further analysis and further design calculation. Pitch circle diameter. All the gears or size of the gear is specified by only pitch circle diameter. So gear is specified by pitch circle diameter. both the pitch circle diameter on pinion and pitch circle diameter on gear meet at common point. That point is called as pitch point, or it is called as point of contact. It is denoted this point, pitch point, and these two circles are tangent to each other. These circles, pitch circle diameter of pinion and pitch circle diameter roll on each other. Next is module. This is denoted by small m, capital letter M. It is the ratio of pitch circle diameter to number of teeth. It is the ratio of pitch circle diameter to number of teeth. Mathematically, module is the ratio of d by t. If I am writing here small d by small t, number of teeth, this is denoted for pinion as it is smaller in diameter, so I am using small letter d and small letter t. As d is the diameter and it is measured in mm and t is measured in number of teeth, so the ratio is having the unit mm. Module is measured in mm, and capital D by capital T I am using for gear. So module is nothing but D by T. The standard value for the module is, as per IS standard, is 1 or 1.25, 1.5, 2, 2.5, 3, 4, 5, 6, 8, 10, 12, 14, 16, 20, 22. Extra. These are standard value, Indian standard values for module. For measuring the teeth of pinion with the teeth of gear, the value of module for both the wheels should be same. At that only the teeth of pinion and teeth of gear will mesh with each other and it will transmit the motion and power. If the value of module will be different for both the gears and pinion, the teeth won't mesh with each other and power will not transmit. So this is an important parameter for transmitting and designing stage. Next is a circular pitch and it is denoted by PC. It is the distance measured along circumference of pitch circle from a point on one tooth to the point on corresponding point on next tooth. Here you can see circular pitch. If you consider this point on the one tooth and it is measured along a pitch circle, this is the pitch circle, so it is not a straight line, it's a circular line. Pitch circle is the circle on the gear teeth and it is a circle, so it is not a straight distance, it is a circular distance. So this is the point on one tooth and the corresponding point on next tooth, immediately next tooth. This circular distance which is measured on the pitch circle is a circular pitch. So the formula will become for circular pitch is equal to pi, as it is on circle, so pi value will introduce in the formula, pi into d by t, which is nothing but module, and is equal to pi into m. Next is diametral pitch, and it is denoted by p suffix d. It is the reciprocal of module. This value is again required for design part and for further analysis part. So diametral pitch is nothing but a reciprocal of module. So module is nothing but ratio of d by t. So diametral pitch will become here t by t, or it is again pi divided by circular pitch, and circular pitch is nothing but again pi into module. So pi will get cancelled, and again you are getting the same value 1 upon n. Next is addendum circle. Addendum circle, it is the circle drawn through top of gear, and dedendum circle, it is the circle drawn through the bottom of gear teeth. It is also called as a root diameter. If you see figure here, this is the top of gear teeth and this is bottom of gear teeth. So addendum circle is the circle which is drawn through top of gear teeth. It is denoted by green dotted line, and this is the top land. So circle which was drawn through the passing through the top land is nothing but addendum circle, and the circle which is drawn from the bottom of gear to this is the bottom. This is bottom land. So through this bottom land, if you draw the circle, that is nothing but a dedendum circle. By blue line, you can see here dedendum circle. If you see any gear, you can see these three circles. One is a pitch circle, which is most important. Second is addendum circle, which is passing through the top land of the gear tip. And third one is dedendum circle, which is passing through bottom of gear tip. So dedendum circle is inside circle. The value of dedendum circle is always less than pitch circle diameter, and addendum circle is outside of pitch circle diameter. So value of addendum circle diameter is always greater than pitch circle diameter. All these three circles, addendum circle, this addendum outermost circle, pitch circle diameter, and dedendum circle is always concentric circles or parallel circles. Next is addendum. It is the radial distance on the gear tooth from the pitch circle to the top of the gear. Again, you can see here in this figure, it is the radial distance. This is a radial distance. This line will pass through the center of the gear. Center of gear. This radial distance, this distance is measured radially from pitch circle diameter. This is the pitch circle diameter, pitch circle, to the addendum circle. So it is a straight distance. It is not a circular distance. Pitch circle is a circular distance. So pi value will introduce in the formula. But addendum circle or addendum distance is a straight distance measured along the radial, measured along a radius. So this is the addendum, which is measured from pitch circle to the addendum, and second is dedendum. Dedendum is the radial distance measured from pitch circle to the dedendum circle. It is again a straight distance. It is not a radial distance, and it is measured along radius of the gear. Next is face and flank. Face and flank. Again, you can see here in this figure, face. Face is that part of the tooth surface, which is above the pitch surface. This yellow shaded portion above the pitch circle. This is pitch circle, and from that pitch circle, which is made, which you can see up to the top land, it is nothing but face. It is called as a face. And this yellow shaded portion below the pitch circle line is called as a flank. So it is the surface, it is that part of tooth surface which is below the pitch circle. So the surface above the pitch circle is face, and the surface below the pitch circle is called flank. Next and more important is nothing but pressure angle. Pressure angle is denoted by phi. It is the angle between the common normal drawn at the point of contact, which is nothing but pitch point, and the common tangent to the base circle. See, in every gear there are three circles. One is base circle, or which is near to the dedendum circle. Second one is a pitch circle, and third one is a addendum circle. O1 is the center of pinion in the gear pair, and second is a gear. O2 is the center of gear, and this is again three circles for gear. This is base circle or dedendum circle, pitch circle for gear, and this is addendum circle of gear. So now pressure angle is nothing but the line passing through the common tangent point. So tangent point you can see on pitch circle of both the wheels. This is pitch circle of pinion, this is pitch circle of gear. So P is the common tangent point, and through that tangent point, line which is passing, which is nothing but common normal line. TT is common normal line, and second one, the common tangent to the base circle. This is the base circle of pinion, and this is base circle of gear. So line AB is the common tangent to the base circle. So angle made by line AB and line TT is the common tangent, and AB is a common tangent to the base circle. This is, you can see, common normal line to both the gears, and AB is common tangent line to both the base circle. So angle made by line AB and TT is nothing but pressure angle. Pressure angle. This is very important to understand while solving the numericals, and there are standard value of pressure angle, which is nothing but 14.5 and 20 degree. These two values are used while solving the numericals if not given in the question. Nowadays, the gears with pressure angle 14 and a half is obsolete in the market. Nowadays, the gears which are available in the market is of 20-degree pressure angle. And next is a speed ratio or gear ratio or velocity ratio. All the terms are same and it is denoted by G, the capital letter G. It is the ratio of speed of driver wheel to the speed of driven wheel. Driver wheel is a pinion and driven wheel is gear. So gear ratio will become omega 1 by omega 2, which is nothing but angular velocity of rotating gears, or you can say n1 upon n2. n1 is nothing but revolutions per minute for pinion divided by a revolutions per minute for gear wheel. It is again denoted in terms of diameter of wheel is nothing but d2 diameter of gear to the d1 is nothing but diameter of pinion, which is nothing but a reciprocal of speed values of driver to driven. Here the ratio of diameter of driven to driver. Again it is written in terms of number of teeth. It is the teeth on driven wheel to the teeth on driver wheel. So this is regarding about the terminology in spur gear which is required for further analysis and design part. So thank you so much.